Right, guys, Mamelani, listen up. We spoke about fishing later on. We spoke about fishing. We spoke about the conservation. But now it's time for weather, ne? Right. What influence does weather have on maritime or shipping operations? Right. So we've got major weather systems that do affect the shipping operations, such as the depressions, such as the monsoons, tropical cyclones, tropical revolving storms, the gales, mid-latitude cyclones as well. Do you understand? So we'll be touching on that, on what effect do these weather systems have on shipping operations, at what cost. If they happen, what is the impact of those in as far as shipping operation is concerned? Right, the first one will be depressions. I think I gave you a map last week, and it? Right. So you will have your map here. Mine will not be as perfect as yours, right? But it will be a map. Right. We said we've got depressions. First in grade 10, we would have learned about there are different oceans, and it, whereby you have the Pacific Ocean, and then you've got the Atlantic Ocean, and then here you've got the Southern Ocean, and then from here at the bottom here we've got Antarctic Ocean, and then on this side we've got Indian Ocean. Right. So these weather systems, they occur in different areas, and then when they occur in different areas, we call them in different what? In different names. Do you understand? Right. There is a system that occurs here in this area. There is a system that occurs in this area. There is a system that occurs in this area. There is a system that occurs in what? In that area as well. There's also a system that occurs in that area. Do you understand? But now, what are they called here? Right. If it occurs in this area, which is the Southern Ocean, they are called depressions. If they occur in this area, they are called what? Mid-latitude cyclone. So another name, let's label this as A and B. If they occur in A and B, another name for a mid-latitude cyclone is a depression. Do you understand? On this side, which is C, if they occur on C, they are called TRS, which is, can you guess what TRS stands for? Tropical revolving storms. Known as tropical cyclones. Are we on the same page? Right. If they occur here, which country is this? This is India. Right. If they occur here, they are called monsoons. If they occur here, they are called? Yeah. Coast of Japan? Typhoon. Right, let's add the other one. If they occur here, oh, still remember. So now, since 90% of goods are transported by water, do you see that the more frequent these storms are, the harder or the more difficult it is for us to what? To do a transportation of a cargo from point A to point to point B. Do you understand? So what do we do if they occur? It can happen if they occur here and we have a route from here to what? To China. Do you understand? Yes. So it's going to impact the life on board the what? On board the vessel. It's going to impact the life on ports surrounding the tropical storm. Do you understand? But luckily for us, when these storms occur just east of Ilentuka, in Madagascar, in Mauritius, luckily enough for us, we've got Madagascar, which shelters us from a severe impact of what? Of these storms. Do you understand? Yes, so this island nation called Madagascar, it shelters us from. But if should it happen, this storm passes Madagascar, it's going to impact which area in South Africa? It's going to impact which ports? Let's name the ports. Which ports in South Africa should this mid-latitude cyclone pass? Madagascar. This London is where? Is at the bottom. Durban, Richards Bay. So likely, a port that is likely to be impacted by this storm will be what? Will be Richards Bay. Because it's on the north coast of the what? Of KZN. Do you understand? So what do we do if a tropical revolving storm occurs and we have a route going to Europe? Do you understand? What do we do if a depression occurs and we have a route to India, or we have a route to Japan or to China? Do you understand? Yes, sir. Right. There is something called weather routing. There are benefits to this concept because what we do here, as we all know that the weather starts from where? At sea. Do you understand? So we can be able to identify where does the mid-latitude cyclone occur, pinpoint it, check the speed at which it travels, so that we can know at this time where will the storm be. Do you understand? Yes, sir. Are we on the same page? Right. Right. We said depressions will occur on which oceans? On the Indian Ocean. And South Atlantic Ocean as well. And as well as North Atlantic. In your map, it shows where on areas I've highlighted the areas in which the depressions they occur. Are on the same page? So what happens with depressions? In South Africa, you have a South African map. You have a high pressure system. We've got the northern hemisphere. We've got the southern hemisphere. These lines, they are called what? Isobars. So they are lines of equal pressure. Do you understand? So in the southern hemisphere, right, the direction of a depression is a clockwise direction. In the northern hemisphere, the direction of the isobars. So its direction is an anti-clockwise. Lena, we said the depression ihamba in a what? In a clockwise direction. So in the southern hemisphere, we said kuyenzeka kube khona a high pressure system, kuyenzeka kube khona intoni? A low pressure system. A high pressure system will be determined by what? By isobars with what? With the ilentuka. Umelendon lo? MP stands for what? Yes, it's millibars. Do you understand? So this will determine, the pressure will determine whether we have a what? A high pressure system or a what? Or a low pressure system. Give a right. High, low. Yes. High in the southern hemisphere. High, anti-clockwise. Right. And then this part where the isobars elongates, it's called the reaching of the what? Of the isobars. This part here is called the reaching of the isobars. Guys. Right. And then remember, I'm not sure if you did correct on the diagram up. We'll show you something like this and something like this. Right, on this one it's written. On this one it's written according to your notes. Cold front, this one. But it's a what? It's a warm front. Let's correct that mistake. And then this one is a what? Is a cold front. If you did not correct the diagram, please do so now. So this one is a cold front, and then this one is a what? Is a warm front. Right. Now, when this low system or high pressure system occur, what impact do they have on shipping operations? If a vessel passes from the Southern Ocean to Japan, what impact will it have, for an example, in ports? What impact will it have on board the ship? So these storms, all of them, they are associated with what? They are associated with strong what? With strong winds. They are associated with heavy seas. They are also associated with what? What is missing? We've got strong winds, we've got heavy seas. Short and on, heavy rain. Partially correct. Heavy what? Heavy rain. So imagine you've got strong winds, you've got heavy seas, you've got heavy rain. First of all, what problem does this cause on board the ship when we're navigating from point A to point B? On board the ship, if you've got heavy rain, you've got land that is called restricted what? Restricted visibility. Yes. More especially if there is heavy seas. Obviously, there's going to be a sea spray on board a ship and it. So if there is a sea spray, and then also if there is what? There is heavy rain, it means you will have what is called a restricted what? Visibility. So if there is restricted visibility, it means that even the speed will be what? Will be reduced. If your speed is reduced, what's going to happen to your ETA? Hands up. What's going to happen to your ETA to Japan? Huh? Delayed. Right. So now we said these lintugas, these high pressure system and low pressure system are also associated with strong winds. For an example, take a look. If you are in port, you're loading containers. Containers are worked in what? In suspended heights and it. So if they are worked in suspended heights, there is heavy winds. How is it going to impact the cargo work? How is it going to impact the cargo work? If there is strong winds. Huh? No, we're loading the cargo now. We're talking about containers that are being loaded. What's going to happen to them? Right, if containers will swing on either side. If those containers swing, it means that even the crane might be what? Might be damaged. The wires might what? Might snap due to the high pressure that is caused by those winds. Do you understand? So what does it mean for cargo work in terms of container ships? It means there will be no loading, or loading will be what? Will be delayed. If loading is delayed, what's going to happen to the ships that are expecting? Let's say, for an example, you've got Imekalo loading in Durban, a ship. You've got Imekalo loading in Durban, and then there is strong winds causing suspension of what? Of cargo operations to Imekalo. And then we've got MSV, PSJ, that is bound to load in Durban immediately after Imekalo. Means that there's going to be a lot of what? Of traffic outside the what? Outside the Durban port. Do you understand? Yes, sir. Are we on the same page? Now, there is port operations. What's going to happen on board the ship? Will you be able to sleep? No. Because the vessel will be rolling and it, pitching and it. Right, what's going to happen to the life on board? Will the catering department be able to prepare food for you? No. They will not be able to, because it's what? It's very what? Dangerous. Are we on the same page? So even life on board will be what? Will be difficult. Even walking, you will not be able to what? To walk in a straight what? In a straight line. Do you understand? So you need to hold on to something if you are what? If you are walking. Which means that it might cause an injury to any crew member that is not maybe conscious of the situation. Are we on the same page? Yes. So these storms will come with these three: strong winds, heavy seas, and heavy rain. So in this case, you are expected to know where do they what? Where do they occur? And also know what impact does these three have on port operation? What impact does heavy seas cause on what? On shipping operations or navigation? Are we on the same page? Imagine you are loaded maybe with a 300 meter, you are on a 300 meter vessel in terms of length. You've got heavy seas, meaning that the swell is high as how many meters? It's 8 meters sometimes. It's even 10, 12 meters high. Do you understand? Mr. Mhlakaza is 1.6 meters. Do you understand? So if I'm 1.6 meters, you times me by how much? By 3 at least. Do you understand? Or 2.5. Are we on the same page? In other cases. In other cases, it's up to how many? 12 meters. You can have the whole, it's a whole wave washing up the what? The deck, the main deck. Where is this ship? Oh, yeah. Let's paint a picture. You can have a wave this high. You can have a wave that high. Imagine if you are on deck at that time of the storm. That is why they always say all hands on what? All hands on deck, because we do not know what might happen during a what? During a storm. We might have a man overboard, or a container might fall overboard. Do you understand? So that's why we need to account for each and every what? For each and every head. Do you understand? Are we on the same page? Right. So we said upper they are called tropical revolving storms, which are tropical cyclones, depression or mid-latitude cyclones. In this case, they are called monsoons. In this one, there are monsoons in that direction. There are monsoons in that direction. What are these called? This direction. This direction. Which direction is this? Huh? Which direction is this? Which direction is that? Which direction is that? We've got northeast. We've got southwest. So we've got northeast monsoons, and then we've got southwest monsoons. And then in this case, Japan, or off the coast of Japan, we've got a name called typhoons, and then along the coast of Australia, willies. Let's go to the next page. I think you should be able to see a cross section of your depression. Cross section of your depression, whereby it shows you A, B, C, D. A, B, C, D. It starts with D, C, B, and then A. So there, something like this. I want to explain so that you understand. So when it starts, when any storm will start, we start with the formation of what? Of your high clouds. Do you understand? So then they become to become what? They become too much what? Too much dense. And then, in any case, you've got land octua, which is called the eye of the what? Of the storm. That is also known as the area of what? Of calm. If, I don't know if it's going to be a miraculous situation, if you are in the center of the storm. If you are in the center of the storm, there is sunlight there. There are no clouds. Do you understand? If you are in the eye of the what? Of the storm. It's the area of what? Of calm. But surrounding areas of the storm, that is whereby you get your heavy winds, your turbulence in terms of the wind, your heavy seas. So in area A, your clouds will start to what? Will start to what? To form, whereby you get your what? Your warm front. And then as it moves to area B, and then it starts to what? It's a warm sector. It starts to give you the direction of the wind. In this case, it's a northwesterly wind. And then it starts to what? To strengthen, to gain strength as it what? As it passes. Do you understand? And then we get to area C, whereby there is too much of turbulence, where there is heavy, strong winds, there is heavy seas, there is what? There is heavy rain. Is it possible for you to be there in the center of the storm? Is it possible to be in the center of the storm? It's not possible to be in the center of the storm, mainly because surrounding areas of the storm. That is why they usually say you need to keep 200 nautical miles away from the what? From the storm eye. So you need to be away, where? 200 nautical miles away from the what? From the eye. For your vessel to experience less of A, which is strong winds, less of B, which is heavy seas, less of C, which is what? Which is heavy rain. The more you are away from the what? From the eye, it means by your vessel in terms of maintaining the stability of the vessel, because you know when you experience these heavy seas, there's something that is called cargo shifting. And then we have landed that is called weather routing. What is weather routing? Weather routing, it is to do a routing yet. If we see that we're going to have a storm or a depression in our direction, it will mean that we need to route a vessel here to away from the what? We are routing a vessel here to away from the what? From the storm. Should we encounter another storm, we route a vessel. If it goes in that direction, it means it's safe for us to route a vessel here in that direction. And we closely monitor what? We closely monitor the position of the what? Of the storm in relation to our position. Do you understand? Because how does that help? For an example, these storms here, they've got a tendency of going in that direction and then come back. Do you understand? That is why it's revolving. It goes and what? And comes back. Do you understand? These more especially the tropical cyclones. Other ones, they've got a tendency to go in that direction, meaning that if this occurs here, it means that we need to plot it away from the what? From the storm. At all times, we always monitor the position of the storm and in relation to the position of the what? Of the ship. What do I mean by cost savings? Another learner will say, no, sir, it can't be cost savings because the intended route was like this, sir. No, sir, the intended route was like this. So how is it cost savings? Because when you compare these two routes, this one will travel more nautical miles. Do you understand? In relation to the initial route or the initial intended route. So how is it cost savings? If these storms occur, it means you need to have a safe shelter. Where are you going to shelter? Where are you going to shelter? What's the best place to shelter a vessel? What's the best place to shelter a vessel? Port. Right. So in port, we're saying that the best place to shelter a vessel is where? Is in port. Do you understand? If it is in port, if you do not want to get in port, what do you do? Anchoring. Where? Away from the what? Away from the storm. Do you understand? So in other words, if that storm is that much severe, would be, instead of going to anchor in Durban, we might anchor along the eastern or the wild coast, Lentuka coast. But what impact will it have? There's going to be delayed ETA. Because we're going to wait for that storm to dissipate. Because as soon as it reaches land, remember, between Lentuka, Madagascar, and South Africa, there is that Mozambique channel. So if it starts from here, Madagascar will shelter us. Do you understand? And then if it passes Madagascar, it will go via to the Mozambique channel, and then it gets to land. So immediately when the storm reaches land, it loses strength. When it reaches land, it loses strength. Do you understand? For an example, if you are in a situation whereby there is wind coming from that side, that's a windward side, and then this is a leeward side. In this setting, from that side, you'll experience more wind. And then we've got this structure which is acting as a what? As an interference. So meaning that people on this side will not experience what? As much turbulence in terms of what? In terms of the wind. So as it passes through, it loses the what? The strength, due to the fact that there is a what? There is what? There is a disturbance in between. Do you understand? But if there is no disturbance, it continuously gains what? It gains the strength. Until it reaches what? It reaches the land. Are we on the same page? Yes. All right. And then we've got land actual, which is called early arrival of ships. How is it early when we're going to take a longer route than intended voyage? How is it going to be early when we're going to take a longer route than intended route? Remember, we said the first option is to anchor. While you're anchoring, waiting for the port, for the storm to dissipate, what you're gonna do? You're gonna wait until it what? It dissipates. Do you understand? Two vessels, one vessel had anchored, another had left immediately, even before the storm started. And then they did landed. That is called the weather routing, whereby they routed their vessel away from the what? From the storm. By the time they are here, maybe you will be leaving the port. Do you understand? Yes. Meaning that if you had the same ETA initially, it means that this guy is going to arrive first in the next port of discharge. Do you understand? So this will be your homework. And then we've got by 2 up and clinic. Okay. Right, listen up, guys. The first one. Right, before you attempt to answer, always analyze the question. What are you given in that question? For an example, in this classwork, you've got the Cape colors. It shows you Cape colors. Can you identify where the ship is? Can you identify where the ship is from your copy? Where, on which waypoint? Waypoint number 1. Where is the ship? Start counting from the right-hand side. Can you see where the ship is? Can you see? Start from this side. You see where the route is. Count the waypoints. You've got waypoint number 1. Next to waypoint number 2, there is a dark shaded ship there. Can you see it? Yes. Right. Okay. All right. So now, what we have there, it's a weather map showing the conditions of the storms that we just spoke about, which is the depression. Right. And then you've got straight lines that will indicate the course of the ship with different waypoints, and it says one and it. Where is the ship going? In which direction is the ship going? It's going towards Europe, and it's coming from the east, from the wild coast, and it. Right, and then you've got this thing. Saibon, Anna? Are we on the same page? A full feather is 20 knots. In terms of wind speed. So in that feather, there are 2 things. You've got wind speed, and then you've got the wind direction. Are we on the same page? And then we said we name our winds according to where? To where they're going or to where they're coming from? We name them to where they what? So in this case, if we were to name this wind, that's what the AP wind. Northerly. Okay, so if that was the wind, in which direction is this? Southwesterly? Southwesterly wind. If this wind was like this, in which direction? Northeasterly wind. We said we name them according to where? Where they come from or where they going? Right. Origin, and it? Origin. That is the origin. In this case, that is the origin. Are we on the same page? Right. You will sometimes have something like this. Or it's clear, or it's shaded. What does it mean? Outcast. No. It's what? Outcast. So overcast is whereby we're checking the density of the what? Of the clouds. Are on the same page? So in this one, you might conclude, Uba, it's what? cloudy. This one, it's what? Clear. Do you understand? Are we on the same page? And then we said 2 feathers will amount to 20 knots. It means about this feather alone. We're talking about these 2 feathers. It's 20 knots. This feather alone is what? Is 10 knots. This one is 10 knots. If it's half a feather, it's 5 knots. So if you've got 2 full feathers, in other words, in total, how many knots do you have? 25 knots. In this case, that will be the speed of the what? Of the wind. The faster the wind, or the stronger the wind. But the stronger the wind, sakhumbula la heavy seas. Do you still remember heavy seas? So the heavier the what? The heavier the wind, the more you're going to have indoni, heavy seas and what? And the swell. Do you understand? If you remember in physics, there's something like this. Which graph is this in maths? Which graph is this in maths? Huh? Which graph is this in maths? Huh? It's a tan graph. It's a sine graph. It's a cosine graph. Oh, it's a cos graph. Huh? So you're telling me in grade 10, grade 11, you did not do trigonometry? All right, Mamelad. Listen up. I think even in physics, you should remember this. So you've got these points here. This is a turning point. All right, guys, don't disappoint me. And then we said, it's a what? It's a true or trough. And then this one? Aye, here at the top. Crest. At least you still remember something. Crest. And then this one? And then this one is a what? Is a wavelength. Do you understand? And then this one? This one is amplitude. I don't know how you forgot this, but it's fine. We said the wind speed, the faster the speed, the more frequent your waves or your swell will be. Do you understand? Are we on the same page? Right. If the stronger the wind is, then your swell will start to what? To increase in intensity in terms of the what? In terms of the what? Of the amplitude. Meaning that the height of the wave will then start to what? To increase. As it gets stronger, it can get up to 45 knots. Do you understand? For an example, if you were to blow, if you can put water in this, if you can blow, what would you see? You will see wind. You will see what will you see? You will see the swell. Do you understand? Are we on the same page? But the faster you blow, the swell will start to increase into what? In terms of the intensity. Do you understand? If there are 4 people blowing at the same time, we might even see water spilling over. Do you understand? Yes. So that's a basic concept of how the wind impacts on the what? On the heavy seas. Are we on the same page? Still on the same page? Right. And then we've got different directions. We said a diamond shape, its wind speed above 50 knots. If you don't even come near the area where there is what? There is diamond. Do you understand? You might find something like this, shaded black diamond like this. We are talking about 50 what? Knots. 50 knots of wind on a vessel such as a ro-ro vessel with a high surface area, or fully loaded vessel or container vessel with a huge surface area. Do you think it would be easy for us to navigate through that 50 knots? It's not going to be pleasant. Do you understand? You might even have containers falling overboard. Or even yourself if you did not harness yourself safely. Do you understand? Right. So you'll analyze that. It was taken from mixed line. Note where the vessel is. Do you understand? Note the direction of the what? Of the wind. Are we on the same page? Stefan? Right. And then you'll answer those questions. Should you have trouble or problem, you'll raise your hand, sir. Can you please further explain 1.1 or 1.3 or 1.4? Give a And then when these other guys come back, and then the other three will follow. In that order. Are we on the same page? Uh, 1.1, you look at the wind speed and the direction. In what season was the voyage from Durban to Walvis Bay undertaken? We've got 4 seasons in the year. Which season? 2. Siyabona, where is the position of the vessel? Yes. In which season do storms like this occur around Cape Town? You've got also notes to assist you as well. You've got your textbook to assist you. You've got Mr. Mhlakaza to assist you. Right, I'll be standing by immediately when you are done with question 1.1, you'll raise your hand, then I'll come and mark. If you've got trouble, then I'll come and explain. Are we on the same page? You said where the line starts, and then that's waypoint 1, and then that's waypoint 2. So next to waypoint 2, you've got that vessel. In which direction is this vessel heading? Here towards Europe. Do you see? Right, so what you need to do is to analyze that map first before you do any answering of any questions. You need to check what are you given. In other instances, they might give you something like this, whereby they will say, for an example, they will say it's a what? It's a warning. Whether it's gale or it's typhoon or whatever, and then they will then give you the direction. They will also say the wind speed. They will also tell you about the what? The sea state. Or they will tell you about the what? The swell. They will also tell you about what? About visibility. Are we on the same page? So if it's something like this, you also analyze the direction of the what? Of the wind speed, the sea state or swell, the visibility. Usually visibility when you've got 15 meters or 12 meters high of Ilenduga of the sea swell, it will mean that there will be sea spray on what? On board the ship, and it. Also, if there is going to be heavy, and it we said they are not only associated with heavy seas, they are also associated with what? With heavy Rain. They're also associated with what? Aye. The wind is not heavy. The wind is what? Is strong. Are we on the same page? Can you weigh the wind? No. But you can weigh in terms of the strength of the wind. Do you understand? Are we on the same page? So we said these storms are associated with heavy seas, heavy rain, strong winds. What you need to do is, whenever you are given a question, know the impact of wind in terms of what? In terms of cargo operations. In terms of what? Of shipping operation. The same applies to the rain, the same applies to the what? To the wind. Safe navigation, heavy rain, whereby visibility is what? Is restricted. What impact will that have? It means we're going to have to decrease the what? The speed of the vessel, therefore delaying your ETA to the next port of discharge. If you're going to discharge to the next port of load, if you're going to be offloading. What impact will this strong winds have on shipping operations, on cargo operations? For an example, if you are loading grain is loaded in bulk quantities, and it. So if you're loading grain into a bulk carrier, it's loaded, it's loose. If there's strong wind, what's going to happen? If there is wind and then you let go of the sand like this, it can get blown off. So you might end up losing what? Losing cargo. Do you understand? And most especially, heavy rains. You need to apply it on each and every what? Type of vessel. What impact does heavy rain have on loading ro-ro vessel? For an example, let me ask. Ro-ro vessel, we're now loading ro-ro vessel. What impact will heavy rain have? Okay, when it comes to loading of ro-ro vessel, rain does not have any what? Any impact. Whether there is rain, whether there is no rain, we can be able to load the vessels. Do you understand? Unless if it's hail. If it's hail, it's caught, and it. So if it's hail, it will damage the screens. It will screens of cars. Do you understand? So in that case, we cannot offload, and then we can also not load. Do you understand? But strong winds again. What impact will it have to load a ro-ro vessel? No impact. We can still load a car into a ro-ro vessel if there is what? There is strong winds. But that strong wind will impact the ro-ro vessel when the ro-ro has to what? Has to move, or to have to what? To sail. Do you understand? It will be difficult because of what? Of the what? Huh? Because of the what? Because of the wind, because of the huge surface area. Do you understand? Because indeed we said that they've got a higher freeport. So if they've got a higher freeport, it means the wind will actually blow. If it blows, it will blow on a huge surface area, meaning that it will have a greater impact on the stability of the what? Of the ro-ro vessel. Do you understand? You will even have cars, maybe, even though they are secured, but it will cause a stability what? A stability problem. Do you understand? Yes, sir. And also, when you take strong winds, we're talking about loading cars, but if you apply strong winds in loading containers, it's a different scenario because containers are loaded in suspended what? In suspended heights, meaning that it's going to be impossible for us to what? It's a working hazard to load a container. One, that crane might snap, it might get damaged, maybe, even though you know, as someone who works with things that are in suspended heights, that you are not even allowed to walk underneath a suspended object. You cannot walk under a suspended object. But if it swings like this, it's going to cause a problem for the what? For the crane. It's going to cause a problem for the cargo that is inside the what? Imagine if those the container is full of what? It's full of wine glasses, for an example. And then immediately touches the ground. Upon impact, the whole thing is what? Is gone. Do you understand? So you need to apply for each and every what? For each and every type of cargo. Do you get me? Strong winds. Container ship will not be able to leave the port. The Ro-Ro vessel will not be able to leave the port. But it's a different case for what? For a type of vessel. A bulk carrier. Because it sinks deeper into what? Into water, and therefore less freeboard. Do you understand? Meaning that there is less surface area for that impact of wind. Do you understand? Are we on the same page? So now you will have something like this. Which part of the vessel do you see from here? Stern. You see the stern. So where is this vessel facing? That side. Do you understand? Are we on the same page? It's facing as that container ship. You see that container ship? Yes. Right. It's facing, in this case, it's facing that side. So, which side is this? Port side. And then this side? Starboard. Now, when we are talking about port operations, let's include port operations. Let's include port ops. These three that comes with storms will have a huge impact on what? On port operations, shipping operations, and cargo operations. When we are talking about port operations, it will be even harder for tugs or tug masters to maneuver the what? The tug as well. Do you understand? Because as much as there's going to be swell outside the port, some of that swell will be coming into the what? Into the port. Are we on the same page? Meaning that it will also have an impact in terms of pilotage. Will it be easy for pilots to board or to embark or disembark a pilot boat? It will not be easy. Do you understand? Yes. If we are using a helicopter, will it be easy to land that pilot? No. Because the pilot will swing on what? On either side. Do you understand? Yes. You saw that video from Transnet? Yes. So timing, where it says timing is what? Is everything. So you should know when should you embark on a vessel or when should you disembark. Should it happen that we've got something as we all saw in that video about heavy what? About heavy seas. Do you understand? Yes. Are we on the same page? Yes. So you apply in each and every situation. You apply this in each and every type of what? Of a vessel. Do you understand? In terms of this vessel in grade 10, we learned that the Ro-Ro has a huge surface area or a huge freeport. What impact will this have on loading that vessel? What impact will that have for that vessel to what? To leave the port. Do you understand? Are we on the same page? So now answer those questions. You're answering question 1.1 and then you move to the next question. If you are struggling, You raise your hand, say, I do not understand this question. Can you please elaborate this one? We are doing classwork first, and then this one is a homework. This one is a homework.